Hello friends, welcome back to my channel. I hope all of you are doing well. So guys, in our previous videos we have already covered so many topics. So just like how to create service principal in Azure, along with that how to assign contributor level access to service principal using app registration in Azure. This is actually required in order to create Terraform connection with Azure cloud. We have also covered how to create virtual machine in Azure using Terraform configuration files and what all resources are required in order to provision a virtual machine. Along with that, we have also covered how to use variables in Terraform configuration and how to take output of any provisioned resource on Azure, just like we took output of IP address of provisioned virtual machine using Terraform state file. So in today's video, we'll see how we can create a remote backend, or in simple terms, we can say how we can store Terraform state file remotely on Azure storage account. So in my previous video, what we have done, we were not storing it on a remote server, or we were just storing it locally, because by default, when we create anything in Terraform, so state file will get stored locally, but we need to get it stored to remote location, because this is very important concept. It is used in all live projects and we cannot use local storage. We have to use remote storage in all live projects. So let's start our today's video. So in today's video, we'll see what actually is the local backend and what is the remote backend. So we'll see the difference in these two concepts and what are the disadvantages of local backend and what are the advantages of remote backend. So that we'll also discuss. Secondly, we'll see how we can install Azure CLI, because it is very important. In order to create that remote backend, we need to make a connection with the Azure cloud using AZ command. And once that is done, then we'll be able to create remote backend. After that, we'll see how we can create a blob storage on Azure as a remote backend, because if we want to store our state file on Azure storage account, then we need to firstly create a storage account over there and then we can store it on that storage account. After that, we'll see how state file locking provision is there in Azure, because when we use local backend, then in that time, whenever we perform any command just like terraform plan, terraform apply, terraform destroy, at that time we see that Terraform provide a lock on that state file. But is this the same when we store that Terraform state file on Azure storage? So whether that state file is getting locked or not, so yes, it also get locked when we store it on Azure. But similarly, if we do it for AWS cloud, so AWS cloud don't provide any such provision to store or to make a lock on the state file during operation. That's why we need to create one DynamoDB account over there, and there we need to store the lock file. But in case of Azure, we don't need to do it. It is in the functionality by default and it will do it by itself. Then we'll see how we can create resources required to create virtual machine, that we have already discussed, but I'll again explain that what all resources are required in order to create virtual machine, and we'll use the same example as we have already done in our previous videos. So that we'll also do in today's video, and after that we'll see practical demo where we'll see how we can create a storage account and how we can actually push our state file to that storage account, and how that state locking is getting done. So everything we'll see practically also. Okay, so let's see what is local backend and what is remote backend. So local backend, when we don't specify anything for state file storage location, then by default it will use local backend and will store on your local machine from where you are running the Terraform command. So in our previous videos also we were using Visual Studio Code. So if we are running any Terraform command from Visual Studio Code, so as it is installed on our Windows machine, so by default, the Terraform state file will stored on our Windows machine in the same folder from where we are running the Terraform configurations. And what is the disadvantage of using this local backend? So accidentally, if someone delete this file, then Terraform will lost access to your provisioned infrastructure, as terraform.tf state file is lost, and teamwork cannot be done using local backend, as multiple developers cannot use the same terraform.state file as it is locally stored on one of the machine. So these two are the disadvantages which makes us to move from local backend to remote backend. So in remote backend, we can explicitly define the state file storage location, and state file will store remotely and not on local backend. Remote backend that we'll use here in our example is Azure Storage account as a blob storage. So there are multiple kind of storage account also available on Azure. So we'll use blob as a storage account. And what is the advantage of using this remote backend? So what all were the disadvantages of local is the advantages of remote. There is no fear of accidental deletion of remote state file as user is not having access locally. Teamwork can easily be done as every Terraform developer is now connected with the same state file which is sitting remotely on Azure Storage account. Okay, now what was the local backend? So this is one of the snapshot from the previous video where we have just created a virtual machine. So we can clearly see there was a file that is highlighted here, terraform.tf state file. So this file was getting stored on the same directory where we were having main.tf and provider.tf file. So this is actually the local backend. But in order to make the remote backend, what configuration changes is required? If we want to make a remote backend, then we need to place this block. So we don't need to remember anything, as I already told in my previous video also. In case of Terraform, we don't need to cram or don't need to remember anything. We'll take everything from Terraform documentation and then we'll use it. So this is also one of the snapshot from Terraform documentation. So once I'll do practically, then I'll show you from where we can get it and how to place it in our existing configuration. So as I already told that Azure CLI is important to install because Azure CLI is mandatory as we have to make one connection one time with Azure cloud using Azure CLI command. So we'll use AZ login command. Once it is done, we need to just manually verify the login of the account, as already when you run this command AZ login, it will automatically open one browser window which it will try to get it connect with our Azure portal. And once you'll give a manual connection, then it will allow us to run the command related to remote backend. So that I'll show you how we can do it. Okay, so we just have to search on Google that Azure CLI download, and then we need to select install the Azure CLI for Windows. If we are using Windows, then we can select this option, and after that we can go with latest MSI of Azure CLI 64-bit. Once we click on it, we'll see this kind of MSI will get download, and we just need to do a double click and Azure CLI will get installed. So once this is done, we are done with Azure CLI piece, and then we need to create a storage account on Azure. But first let's understand how many kinds of storage account that we are having on Azure. So the very first account is the blob storage. Second account that we have is the file storage. Third, we have queue storage. And fourth, we have table storage. So what is blob storage actually is? It is an object-based storage for unstructured data. File storage is a shared storage for structured data. Queue storage is basically for large number of messages that can store, so it can act as a buffer here. And in case of table storage, it is a kind of structured NoSQL data in cloud. So it is very much similar to the Cosmos DB or what we have DynamoDB in case of AWS. But there is some difference between Cosmos DB and this table storage, some pricing structure or something. So basically both are for non-SQL, and some pricing related constraints are there. So our main point of focus is not as of now table storage. We mainly use, or we are mainly going to use the blob storage. So our focus is on blob storage. So these kinds of storage accounts we are having on Azure. So once we are now in a position to create a blob storage in Azure. So firstly in Azure, whenever we create anything, we firstly need to create a resource group. So firstly we'll create a resource group, and then we'll click on this create button, and then we need to provide the resource group name and the region. So the region that is very near to you, just choose that region. So I'm in India, so South India is the option and the North India are the option. These two are the options that are available as a region for India, so we can select it in order to save some cost. and then we can just click on create. So it will create a resource group. Once resource group is created, then we can click on this storage accounts icon. If it is not coming in Azure services, so on the search bar you can search storage account and you'll get the option. Once we'll go inside it, then we need to click on create option, and then we need to provide the storage account name as highlighted here, and region will automatically be coming as a South India because the resource group firstly that we need to select, so it is the same which is in the South India, so by default the region will become the same. And then in the performance, we don't need to go with premium as premium is very costly. We can go with standard. And in redundancy also, we need to go with locally redundant storage because there are other options related to geo redundant storage, zone redundant storage, but we don't want that kind of redundancy. We are just doing it for testing purpose. So we want redundancy related to our instance only. We don't want this storage account to get redundant to multiple zone and then multiple regions. We don't want to get it done, and this will actually become costly in order to select those options. So we'll go with LRS, that is locally redundant storage. And once this is done, then we need to enable this versioning for blobs because this is required in order to keep all the versions. We need to click on this keep all versions also, because if we want to make some kind of if we want to get something returned back, so the old changes can be returned back using these versions. So these version enabling is a very important feature that we need to make it enable on this storage account. And once this is done, we can go with the creation of the storage account. So creating a storage account is not that much difficult. We just need to follow some screens and we need to select the option. So once we'll do it practically, then I'll show you how easy it's to create just a storage account and how it will be beneficial in order to have our TF state file remotely. So once this is done, then we need to create one container on this storage account. So on this storage account, we can either create containers, file shares, queues, tables, so that I already told. So the other three option is no use as of now. So we'll go with the containers. So in this container, we'll store our blobs. So once this is done, then we'll click on container, a plus icon that is showing on the top, so we'll click on it, and then we need to give the name of the container. So we'll give any name. So as of now I'm giving this test-terraform, so that is okay. And post completion of that, we can click on this create button. Once this is done, we can see that this is the container. So inside this container, our blob will get stored, means our terraform.tf state file will get stored. And this is the provision that we need to do it manually. And as of now, we can see on the right side, lease state is available. So it means this container is ready to take the blobs on it. And this screenshot is actually showing that whether Azure provide locking on tf state file or not. So just like we have store a file prod.terraform.tf state. So on the left side, we are seeing Terraform is not performing any action. At that time, lease status is unlocked and lease status available. And when Terraform performs certain action, so in lease status, we can see it is locked and lease state is leased. So it means that is at this time, if any other developer is trying to get access to this terraform.tf state file, then he or she will get a message that the Terraform state file is locked as of now. So someone else is using. So at that time, multi-operation actually is not allowed in this Terraform state file, else it will get corrupt. So that's why this feature has to be enabled. Similarly, in case of AWS Cloud, that storage account, or what we can say S3, we use in AWS, so that will not help in case of locking because locking is not providing by S3. That's why we need to create one table in DynamoDB table, and we have to use that table for locking purpose. So once this is done, we firstly need to see that what all resources we need in order to provision the virtual machine, because we are going to provision a virtual machine in our today's video. So I have discussed this in my previous video also, that what all resources are required, from where we can get individual code from Terraform documentation section. So everything cannot be completed in a single video. That's why I have separated out that complete video, how to create a complete Terraform script for a virtual machine in case of Azure, and how to get every code from the documentation. So if you are not comfortable with that, so just go to my previous video where I have created one virtual machine using Azure Cloud. Along with that, I have placed one more video where I have shown how to create variables or use variables in Terraform configuration and how to take output of any value. So I'm going to use those things in today's video. So if you are not comfortable with those things, just go to those videos. So those videos will be helpful. So as of now, we'll see what all resources are required in order to provision a virtual machine. So the very first resource is the resource group that we need to do for every resource that we create in Azure. Firstly, we need to create a resource group. And then the second resource that is required is a virtual network. Post virtual network, we need a sub network. After sub network, we need a public IP, and after public IP we need a network security group, and post creation of network security group we actually need network interface also that will be attached to our virtual machine. And after that we need to associate the network security group to our network interface. So in case of network security group we are not doing much, just we are opening certain ports. So we need to assign those open ports to this network interface, and once all these resources get provisioned, then what we can do, we can create our virtual machine. So our virtual machine is actually the combination of all these resources, and once our virtual machine get provision over cloud, we can access it from outside world using the public IP that we have provisioned, and this public IP need to be attached to a network interface so that this can be attached to virtual machine and we can access that virtual machine from outside world. So guys, this all will be the theory related to this remote backend and some other things related to virtual machine. So I hope you all understood the concept of remote backend, but things will get more clear once we'll do it practically. So let's move to our practical demo now. Okay guys, so this is our Visual Studio Code. So this is our main.tf file, which is actually having configuration related to a virtual machine, which I have already discussed in my previous video also. So let me discuss now the resources here also. So the one resources, all the resources that I was showing in my slide. So the very first resource is Azure Resource Group. Second is the virtual network. Third is the subnetwork. Fourth is public net IP. And next we are having the network security group, and here we are opening certain ports, so that's why we use it. Then we are declaring here Azure network interface, and then we are doing network interface security group association in order to associate security group ports to this particular interface. And then here we are using Azure Linux virtual machine related resources. So these all scripts are available on Terraform documentation, so we can get documentation related to these resources step by step. I have created one video where I have created everything step by step for this virtual machine. So in today's video I'm not going to do that because this video will become very lengthy, and I'll use the same code that I have created in my previous video. So this is the same code, so I can keep this code here in the main.tf file, and in the output.tf file I'm just taking output of virtual machines public IP address, because we'll use this IP and we'll get login to the machine and we'll see whether the machine that has been created on cloud is accessible using this IP address or not. So the third configuration file is provider.tf, which I'm not going to show because it is having the service principal which is confidential for the cloud. So I'm not going to show, but I have also shown in my previous videos that how to make service principal or how to create service principal using Azure cloud, and the subscription ID, tenant ID, client secret, the values that we need to get from Azure cloud, and we need to make service principal. So in this file we are having that only, so this I'm not showing as of now. So our main focus is how to make the backend remote. So for that we'll firstly go to Google, and here we'll search Azure, or what we can write, Terraform Azure Remote Backend. Okay, so and when we'll click on this very first link, so here we'll see the documentation related to the configuration for backend related piece. So here we can see that this is basically the configuration where backend will be Azure RM, and we need to pass resource group name, storage account, container name key here, and this section has to be the part of your Terraform configuration. So what we'll do, we'll just copy it. Okay, and we'll go to our Visual Studio Code, and here we'll create a new file by this plus icon, and we'll give it a name backend.tf. Okay, this is actually very good in order to separate out everything, because if I place my output related piece also in main.tf, provider also in tf, backend also in tf, then every time whenever I need to make some changes, I need to touch that main.tf. But I don't want to make this main.tf file unusually access. So I'm creating separate file, which is actually the procedure also when once you will work in any live projects in industry. So we need to actually separate out these files accordingly. So in case of backend, we'll place it here, because backend is not having anything related to our main.tf. So that's why I'm separating this piece with main.tf. So this is now our backend .tf related content, which I have just copied from the Terraform documentation. So we don't need to remember anything. Just what we need to do now, we need to create one storage account on Azure cloud. So here is my Azure cloud. So firstly we need to go to resource group. In order to create resource group, we need to click on create, and here we need to provide resource group name. So let's copy it from one of the notepad. So here I have copied this thing, so we'll make things related to this. So just place it, and the location, as I told you, we can select Indian location, so we can go with South India. And then we don't want to provide any tags as of now, so we can just do next and can click on create. So now our resource group is created. Once resource group is created, we can again go to home. There we can select our storage account, and here we can click on this create button. So once we'll click on this create button, automatically it is taking resource group, the resource group that we have created with test storage account name, and storage account name will copy it from here, because here is some restriction that we need to use certain name only with without any hyphen, without any spaces. So this I have tested, that's why I'm using this particular name. So it's explore DevOps Terraform, and reason has to be the same. Performance, we need to go with standard, and by default it is selecting geo redundant storage, but this is actually costly piece. We don't want to go with it, we can go with local redundant storage. Then we can go to next, and here also I think we don't need to enable anything. We are good with all these options by default. And in case of networking also, as of now we are good with this enabling public access from all networks. Usually in live projects we go with the second option, enable public access from selected virtual networks and IP address, but as we are doing it for testing purpose, we can go with it, so there is no harm. We can go with the next, data protection. In data protection, we need to enable versioning for blobs and keep all the versions also checked, and then we can go to next option, that is encryption. So here also we don't want to make any modification, we are good with all the by default options. And then we can go to review, as we don't want to give any tag, and here we are good with it, and we can go for create. So in this way we can create storage account, so it is not that much difficult in order to create this one. So when we go with the theory piece, it looks like that it is difficult, but once we do it practically, it is easy to implement these things. So it will take some time, let's wait for some time to get it create. And once it will get create, then we'll place these modification in our actual configuration. So this might take some time, as this is not a very big resource just like virtual machines, so it should get create early, but we have to wait until unless we are not seeing deployment completed. Okay, so now deployment is completed, we can go to this resource, and we are done with the storage account creation as of now. But as we know, there are 4 types of storage available on this Azure cloud, that is blob storage, file storage, queues and tables. So we can also call blob as a container. So firstly we need to create a container, just like we create bucket in case of S3. So here we'll click on this container, and here we can give any name. So the name I'm giving from here, copy, and then we can paste it here, and we can click on create. So now we are having our container also created. So now in configurations, we'll modify these things. So we'll copy the resource group name, and then we'll go for the resource group name related parameter here, and here we'll change the resource group name with this, and then we'll make a change with this one also, and then we can make change for this also. This is for container name, and once this is done, we can make key either prod.terraform.tf state, or we can remove this prod here, but we can keep it as it is. There is no issue. Whatever name you want to give it, you can give it here, and then we can proceed. Okay guys, so now we have modified the resource group name that we have created, storage account we have created, container name we have created. So these three are the mandatory thing that we have to change. The fourth one is not mandatory, because the fourth one is the one that we can make of our choice, because it is just the key. So either we can make is a terraform.tf state or prod.terraform.tf state. So we can make any name. It is not mandatory to make it the same name, but the extension has to be .tf state. So now we are good with the backend.tf file also, and if we'll go to our main.tf, then we can now run certain commands here. So firstly, what we need to use the command first in order to check the AZ. Firstly, we need to make AZ login. So we have just ran this command, so it should open one browser window. So this is now open with the browser window, so it will just ask to get this validated. Once we'll click on this, so this kind of page will come, so we can close this page, and once we'll go back to our Visual Studio Code, it will give us this kind of code. So yeah, this kind of code is coming, it means we are good. It has made a connection with our cloud. Now we can run terraform init command first, because if we'll not make that connection first, then there will be trouble, because your Terraform script will not proceed, and it will give you firstly the error if Azure CLI is not there. It will say that Azure CLI is not there, so it is not able to generate the JSON. You need to firstly install the AZ CLI. Once it gets set up and you'll run a command terraform init, it will say that Azure CLI account setup is not there, so please set up an account. So in order to make this AZ login, it is actually verifying that account, and that is done. So now we are good with AZ CLI side also, and we'll try to put Terraform in it and see whether it works or not. So it is Terraform init running, so it is initializing backend. So let's see whether it initialized or not, and yes, it says that successfully configured the backend Azure RM. Terraform will automatically use this backend unless the backend configuration changes. So this time we are not seeing that terraform.tf state file here. So as of now, it is installing certain plugins for Azure RM. So let it get done. And this is actually now clear that we have successfully initialized it. So it has now a connection with our storage account, because if that connection is not successful, we got some error here. So initialization is done. So we are seeing here .terraform file created, and it is also providing a log to this Terraform file, so that whenever from the future version, when we'll run the same command, it will check this file and it will log the version of Terraform Azure provider. So this is now done. Now we can go with Terraform plan. So now when we are performing Terraform plan here, so it will give us what all resources are going to be provisioned on the cloud. So it's a kind of dry run. It is not actual run, but it is just showing us that these all things are going to perform on cloud. So as of now, it is saying that 8 resources are going to provision, and if we are good, we can go with Terraform apply here. And here we are seeing that once we were firing that Terraform plan, we are not seeing that tf state file here, because for fraction of second it come with Terraform plan also, but it is not coming. So we'll go with Terraform apply hyphen hyphen auto hyphen approve, so that it will not ask for approval and it will proceed for creation of the resources. So looks like it is doing something, and it is not asking for input yes or no, and it is provisioning things now. So it will take some time. So in the meanwhile, let's check on the cloud whether we are seeing our file or not. So this is our container, and if we'll go inside it, so we are seeing prod.terraform.tf state file, and as of now we are seeing lease status leased. If we'll click on it, so here we can see that lease status is locked and lease state is leased because some action is performing by Terraform in the backend. So no one else is having access to this particular file. So this will take some time in order to provision the virtual machine. And once that is done, we'll see that the lease status will change to available, and will be able to see that change once Terraform will not perform anything. So as of now, it is saying that it is leased, and what we can do, we can pause this video as this will take some time in order to provision this machine. So let me pause for a minute. Okay guys, so our virtual machine is now completed, and we can see that apply complete, resources 8, added 0, change 0, destroyed 0. So this is basically the public IP that we can copy from here, and we can try log into our machine. Okay, so we are successfully able to log into our machine. So we are good with it. Now let's check our remote state file. What's the condition of it? So if we'll refresh it, now we are seeing lease state as available. So if we'll click on it, and if you'll see here, so lease status is unlocked and lease state file is available. So in this way, locking mechanism is also implemented when we store our state file on Terraform, or sorry, on Azure cloud, because in the case of AWS we need to make provision of DynamoDB also for this locking mechanism. So guys, I'm done with today's video. I hope all things are clear to you, and now you are able to create a remote backend. So in this way we can create remote backend, and as of now we are done with our demo. So we have to destroy these resources as it will consume cost over the cloud. So we can just place a command terraform destroy hyphen hyphen auto hyphen approve, and this will destroy all the resources on Azure cloud, whatever resources we have created. So it is getting now checked with the terraform.tf state file, which is not stored this time locally here, rather it is stored on our cloud. So it is taking reference from here. So anybody who is going with the same configuration in the backend.tf file will have access to this particular state file, and multiple developers can work at the same time because they are not keeping that tf state file on their local, rather they'll point out to the file that is available on cloud. So let's wait for some time. I'm pausing the video so that once all resources will get destroyed, and we'll see whether it is getting successfully destroyed or not. So guys, all 8 resources are destroyed now. It took around 1 minute 17 seconds, as we can see here, and we are good with the destroy piece here. So guys, I hope now things are clear to you how we can create remote backend, and it is actually the mandatory requirement whenever you will work in any live project, because we cannot make the tf state file stored locally. We need to get it stored remotely. So guys, I hope you like this video. If you like this video, please give a like to this video, and please subscribe to my channel, and I'll see you in my next video.